So yesterday we looked at graphing using transformations as a series of transformations. There's another way to graph, and we call it using mapping notation. So what happens is the point x comma y, this is on the parent function or your basic function, becomes the point x over k plus d, ay plus c on the transform function. So what we want to make sure is you guys can pick off the k, the d, the a, and the c. So let's look at this first equation, okay? So if we were, the first thing we're going to have to do is rewrite it. Remember, we always have to factor out the k. So y equals 1/2 square root of minus 2 times x minus 3 minus 3. Okay? So that, just double check, that's negative 2x. And I'm just distributing negative 2 times negative 3 is positive 6. Okay, good. So if we look at that, a is in the beginning. So a, I'm going to write it, oh, it's okay, I'll write it here. A equals 1/2. K equals minus 2. C, oh sorry, this one is D. Or here, I realize this says P and K. Another way to write this is so we can relate to the C and D. A, F, K, X minus D plus C. Okay, that's another way. For some reason they have D coming before C, but that's fine, we'll live with it. D equals 3. And C equals minus 3. Okay? So, first of all, we're going to look at the parent function. Okay? So, let's do a table of values for the parent function. So, the parent function is 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. Okay. Now, the transformed function, we'll just try to squeeze it in as best as we can. Minus 2x minus 3 and then minus 3. So square root of all 2x, 2 times x minus 3 and then minus 3. So now our points become this. The x becomes x over k, which is negative 2, right? So x over negative 2. Our d is 3. We add the 3. And the y values become 1/2 y minus 3. Okay, so what we can do now is plug in 0 there. Our x, we plug in 0. See how I'm going to plug in that 0 there. 0 divided by negative 2 is 0. 0 plus 3 is 3. My y value, 1/2 times 0 is 0. 0 minus 3 is minus 3. Okay. Now I can plug in 1 for x. I'm doing the next point now. That's negative 1/2 plus 3 is 2.5, right? Negative 1/2, I'm doing that one, plugging it in. Negative 1/2 plus 3 is 2.5. And then 1/2 minus 3. 1/2 times 1 is 1/2. 1/2 minus 3 is minus 2.5. Okay, so now I'm working on for the 0.42 on the parent function, and I'm transforming it. 4 divided by negative 2 is negative 2. Negative 2 plus 3 is 1. And then 1/2 of 2 is 1. 1 minus 3 is minus 2. Okay, now let's plug in the 9. Negative 9, well 9 divided by negative 2, negative 4.5 plus 3 is negative 1.5. And I'll plug in the 3 here. 1/2 times 3 is 1.5, minus 3 is minus 1.5. We'll do 16 and that will be the last one. 16 divided by negative 2 is negative 8 plus 3 is negative 5. 1/2 times 4 is 2. 2 minus 3 is minus 1. So now we have the points we need to graph our final graph. Yes?
So how exactly did you get the x over 2 plus 3 and 1 over 2 y minus 3?
Okay, I'm using this formula right here. Okay, so remember when k is 2, we get a compression by a factor of 2. So you're taking all your x values and dividing by 2, and then we're adding the d. So the
Every time we use a root function.
root function, absolute value function, any function. This is for any function that you might run into, okay? We're going to use that for all of it because the effect of the transformations is the same. So let's graph our final, let's graph the parent function, okay? We'll do the parent. 1, 2, 3, 4, 1, 2, 5, 6, 7, 8, 9. Right? There's our parent. Hopefully that is second nature to you by now. Y equals root x. And you should always label your graphs. Label your axes, add the arrows. And now let's graph this guy. 3, negative 3. 2.5 minus 2.5. 1 minus 2. Negative 1.5, negative 1.5, negative 5, negative 1. 1, 2, 3, 4, 5, negative 1. So I will draw that right now. So we can really do our function in one step, basically using mapping notation. So this is y equals 1/2 square root minus 2x minus 3 minus 3. So I want to illustrate that now, the same idea with the absolute value function. Okay, so again, it's very important to always remember to factor out the k so that we can get all the correct transformations. So we're going to rewrite it, y equals 2 0.5 times x plus 4, absolute value sign, minus 5. So in this case, a equals 2, k equals 0.5, d equals negative 4 because it goes 4 to the left. Just try to remember x is disobedient. It's like you tell it to go to the right and he says, forget you, I'm not doing that, I'm going to the left. This you would think is a compression, but it's not, it's actually a stretch. So think of x as disobedient and y is obedient, and that might help you remember. And c equals minus 5. Okay, so our parent function, this is x, this is y. Our parent function is y equals absolute value of x. And this is a nice one to draw actually, because it's, you know, it has two lines. You only need the vertex and two other points to get our two other lines. So here's x, here's y. What do you think the vertex might be? -4, -5. So, okay, so -4, -5. Oh, that's on the transform function. We'll get that one over here, okay? Y equals 2, absolute value 0.5. Since we got it, I'm going to write it in our table of values so we don't. -5, sorry, that's a little bit squished there. Hopefully you've spaced yours a little bit better. But on the transform function, we have to go x divided by k, which is 0.5, which is actually 2x, right? Plus d, our d is a minus, so it's -4. And our y will be, a is 2, 2y, c is -5. Okay. So at least this is nice. We got 1 point on our transform function. I guess for our parent function, we'll just pick some easy points. If x is -4, y is 4. If x is 0, y is 0. If x is +4, y is +4. So let's just draw that in. 1, 2, 3, 4, 1, 2, 3, 4, and we'll get our parent up there. And I just want a straight edge to make it look half decent. So when x is +4, y is 4. 1, 2, 3, 4, 1, 2, 3, 4. Okay, and we just put arrows on the end to indicate it actually goes on for infinity. So let's get a few points. If x is -4, -4 divided by 0.5 is -8 minus 4. -8 minus 4 is -12. Ooh, that's going to go right off the grid. I don't know how much that's going to help us. But anyway, maybe we'll just have to find another point. Y would become 2 times 4 is 8. 8 minus 4 is 3. Let's see, 0, 0 is actually our -4, -5. And +4, that one should work. 4 divided by 0.5 is 8. 8 minus 4 is 4. 2 times 4 is 8. 8 minus 3 is, and that's that 4. 8 minus 3 is, 8 minus 5 is 3. So we have a 0.43. We need another point because that's going to go off the graph. So maybe why don't we try -1, 1. Why don't we try that one? See if that helps us at least a little bit. I'm just sort of just trying to see what works. This is a bit of trial and error here. -1 divided by 0.5 is -2. -2 minus 4 is -6. 2 times 1 is 2. 2 minus 5 is -3. Yeah, that should work. Okay, let's get our points in. 1, 2, -4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. -12, 3. That's right off my grid. So let's do 4, 3. 1, 2, 3, 4. 1, 2, 3. -6, 3, 1, 2, 3, 4, 5, 6, -6, -3, 1, 2, 3, 4, 5, 6, 1, 2, 3. So there is our transform function using mapping notation, and let's just label this is y equals absolute value of x, and this is y equals 2 absolute value 0.5 x plus 4 minus 5. Good. Okay, I'm gonna